Hello learners, and welcome to today's lesson of algebraic expressions. Expand and simplify. Now we are going to start off our lesson with a did you know. So, did you know that algebra has rules? Like any other language, algebra has certain rules that must be applied in order for us to be able to communicate correctly. If these rules are not applied, you'll end up with a whole new language that is not algebra. This lesson will teach us the correct way of communication algebraically. Let's get into our lesson. So now we're going to start off with the things that you should be able to know by the end of this lesson. So by the end of this lesson, you should be able to use commutative, associative, and distributive laws for rational numbers and laws of exponents. You should be able to add and subtract like terms in algebraic expressions, multiply integers and monomials by monomials, binomials, and trinomials. Divide monomials, binomials, and trinomials by integers and monomials. Simplify algebraic expressions involving addition, subtraction, division, and multiplication. So that is what you should know by the end of this lesson. Let's look at our concept map there. We are going to start with adding and subtracting those like terms. Then we are going to go to multiplication of polynomials. And lastly, we are going to end with division of polynomials. So what pre-knowledge must you know for this lesson? So for this lesson, you must know how to recognize and identify coefficients, variables, and exponents in algebraic expressions. You should also know how to identify and classify like and unlike terms in algebraic expression. Then you need to also establish general laws of exponents, namely how the multiplication of powers of the same base and division of powers of the same base. So let's start off our lesson with that pre-knowledge questions. So we're going to start here by labeling the following diagram. Now, can we label this diagram? Yes, let's start with, well, firstly, the expression that we have been given here is 3x squared. Let's start with the 3. We know that that 3 is, yes, a coefficient. So if you said that 3 is a coefficient, then you are absolutely correct. What about that 2? Yes, that 2 is our exponent. And what about the x? Well, yes, that x is the variable and it is also the base of our power. So that is what we have there. Now, let's look at the following expressions and determine whether they are like terms or unlike terms. We're going to start there with 5x and 9x. Are they like terms? Yes, they are like terms, and the reason why we are saying they are like terms is because they have the same variable as a base, and those variables have the same exponent, which is an exponent 1. What about the next two terms? Now we have 3ab and a negative 7ba. Are they like terms? Well, yes, they are like terms because they have the same variables, which is an a and a b, and those variables have the same exponent to the variables. So we can see that that is an exponent 1 for the a and the b, and again exponent 1 for the a as a variable and the b as a variable. Then we have 15y squared and 4x squared. Now, are they like terms? Well, even though the exponent is the same, yes, but we can see that the variables are not the same. So these ones are not like terms. So we can say that they are unlike terms. In fact, we can indicate with all of them whether they are like terms or not. So we've already discussed why these two are like terms, and of course the first two we've already also discussed why they are like terms. Then we have the next one, which is 3p squared q and negative 8p squared q. Now, are they like terms? Well, of course they are like terms because they have p and q as the variables that are the bases here, and then they also have a exponent 2 for the p variable and an exponent 1 for the q variable. Then we have 5m squared minus 2m cubed and 17m squared. Now, are they like terms? Well, these ones we said yes, they are like terms. What about 5m squared and negative 2m squared? We can start with those two. Are they like terms? Well, no, these two are not like terms, and the reason why they are not like terms is because yes, they have the same variable, but the exponent is different, so they are not like terms. But what about the negative 17m squared? Well, we can see that that negative 17m squared is a like term to that 5m squared. Why? Because they have the same variable, and that variable has the same exponent. So those two are unlike terms, but those two definitely are like terms. And lastly, we have 22k exponent 4 and a negative k exponent 4. Are they like terms? Well, yes, they are like terms, and the reason why we are saying that is because they have the same variable and they have the same exponent to that variable. Let's move over to the knowledge that we have of our exponential laws. So we're going to use that knowledge to simplify the following. Now, the first one there says 3a squared times 5a cubed. Now, what we need to remember when it comes to those exponential laws is that when we are multiplying bases that are the same, remember what we do to the exponents? Yes, we add those exponents. So let's go ahead and multiply this expression here. So we have a 3a squared multiplied by a 5a cubed. So we are going to multiply the 3 and the 5. So 3 multiplied by 5, that will give us a 15. And we have now an a squared multiplied by an a cubed. So remember, we are going to add those exponents, and that is going to leave us with 15a exponent 5. The next expression that we are given there is 2p exponent 5q multiplied by 7p squared q. So here we are going to multiply, and remember, when we are multiplying the same base, we add the exponents. When we are multiplying powers of the same base, we add the exponents. So we are going to multiply the 2 and the negative 7. So 2 multiplied by negative 7 is a negative 14. Then we have the p, and we are going to add the exponents of the same base. So we're going to add the 5 with the 2. And again, we have a base of q, and we are going to add the 1. Remember, that q there has an exponent 1. We're going to add it with that 4. So our final answer is negative 14, p exponent 7, q exponent 5. Then the last one there is negative 24k exponent 5 divided by 6k exponent 4. Now, again, we're going to remind you of those exponential laws. Remember, if we are dividing the same base, or powers of the same base, then we need to subtract the exponents. So we are going to subtract those exponents there. So 24, or negative 24 rather, divided by 6, do you know what that answer is? Yes, it is a negative 4. So negative 24 divided by 6 is a 4. And then we are going to just take those powers that have the same base. We're going to subtract the exponents. So our answer there is going to be a negative 4k, and that exponent is 1. And of course, we remember if the exponent is 1, then it is the same as saying the negative 4 with the k, because we know that when we do not see an exponent there, we know that that exponent is a 1. Let's look at the keywords that we are going to be using during this lesson. So we are going to be working with a monomial, which is an expression with one term, for example, 5x squared. Then a binomial, which is an expression with two terms, and that an example for that is 5x squared minus 3. Then a trinomial is an expression with three terms, and that, for example, is 5x squared plus 2x minus 3. We are also going to be looking at a constant monomial, and that is a monomial that does not have a variable. So we are talking about a constant, and because it's one term, then it's a monomial. So for example, a 5 or a negative 8 or a 3. Then we are also going to be talking about a non-constant monomial, and that is a monomial that consists of a variable. So an example of this would be a 3x squared or a 9x exponent 4. Let's go to an ad break and then we'll see you just now.